Last video, we talked about how to open a data set, how to summarize the variables, how to determine the different variable types, and basically how to browse and search through all the data we can see by hand if we want, by opening up and looking at it and look for perhaps potential issues with the data. In this video, I want to talk about how to merge two data sets together into one and how to create new variables from the variables in your raw data. I'm still following along in the introductory Stata PDF, and this should finish it out after this video. I've also decided to make the font even bigger because I noticed I have so much black space on this window. We should fill it up with words to make it easier to see. So I'm going to go ahead and open our Major League Baseball revenue data again. So just to recall what we're looking at, I'm going to go ahead and browse it. So remember, this was the data with the revenue that each team made in millions of dollars, the year, and we had two team variables, one that was a string and one that was a number, but gave us a label telling us what team it was. Now suppose I wanted to combine this data with data from the Bureau of Labor Statistics. In particular, maybe I want to combine it with the CPI. Why would I want to do that? Well, $116.3 million in 1998 is not worth the same amount as it would be in, say, 2012. Because between 98 and 2012, the cost of living has gone up. That's another way to say the value of the dollar has gone down. So these dollar amounts are not actually comparable across year because they don't have the same purchasing power. Now, a dollar in 98 is a dollar in 2012. It's still just one useless piece of paper, but it doesn't hold the same meaning. It can't buy the same amount of goods and services. It doesn't have the same real value, which is what we as economists typically care about. So maybe what we want to do is merge this data with a data set of the CPI in every year so that we can inflate these dollar amounts to all be in the same year's purchasing power. This is something probably all of you or most of you will have to do for your research. So it's good to show you this in the beginning. So I've also given you a data set already in Stata format for the CPI. Let's open that. So I'm going to go to File, Open, and I'm going to find my CPI data. Now I'm going to pause just for a second before I go on, or you should pause the video. Go ahead and explore this data the same way we did in the last video with the baseball data and see what you can find. Okay, assuming you're done, I'm going to go ahead and look at it myself. First, I would just browse the data, very small data set. Actually, let me see if I can blow up these numbers because this is quite small. And we can, fantastic. Let's do 18. There we go, that's nicer. So obviously what I have here is the Consumer Price Index, the CPI, for all the years of our baseball data, and actually more years. Now, the last year in our baseball data is 2012. So typically, we change all the dollar values to be the most recent year. It doesn't matter which one you choose. It just makes more sense when you're doing research to choose the most current year, because then the value of the dollar is more closely aligned with whatever today is. So today is, I record this video in 2022. Obviously, 2012 is a decade away, but it's closer, those dollars are closer in value to what they are today than 1990 dollars would be, right? And actually, we're in the middle of some serious inflation, so maybe literally yesterday's dollar isn't worth what it is today. But we want to get as close as possible, so let's just choose 2012. So we can merge this data with our MLB data, and what we want to match up is the variable year. So for example, whenever I see 2012, say for the Dodgers, I want to attach this CPI value to that row. When I see 2012 Cincinnati Reds, I want to also attach this value of CPI because it's the same year. So what we want to do is merge the two data sets into one based on the value of the variable year. And it's important here that the variable be exactly the same. You see we have a year here, we have a year in MLB, but we need the variable to be spelled the same, right? No, not even a capital Y here. It's got to be exactly the same. And luckily I made it the same for you, so we're not going to have any problems. So what I will type is the command merge. And I'm going to say merge 1:m. That stands for one to many, because in the data set we have right now, each year appears one time, but in the data set we're merging with, the MLB revenue data set, the value of year is going to appear many times. We have 32 2012 years, right? One for each team. So I'm going to say merge one to many, use the variable year, and then I'm going to say using, and then I'm going to have to give it the data set we're going to merge with. So as you can see here, this is the address of mine. It's currently here. I'll just copy and paste that. So what I'm writing here is merge one to many on the variable year using this data set. Now you can see I got a message here. It's not in red, so it's not a problem, but it says the variable year was an integer. So it was stored as an integer variable. Now it's a float to accommodate using data's values. So it's saying, hey, the data type was different, but it's okay, the values are the same, we're going to use it anyway. I just want you to know that in your CPI data, your year was an integer, and now it's a float variable. Didn't change any values, it's just telling you the storage format is different. We also get this nice review window, or table, I should say. It says that 10 rows did not match. 10 of them were from the master data set. You can see here it says underscore merge equals 1. None were from the using data set, underscore merge equals 2. And 450 of the observations matched, or merge equals 3. Now, what is this underscore merge? If you look over at the variables tab, let's click that, you see there's a new variable called merge. Well, what is that? How do we explore a variable? Well, let's describe it. Start there. Describe merge. Oh, underscore merge. Looks like it's a storage type byte, so it's going to be numerical. There's a value label, and there's a variable label, which tells us what the variable is. It is matching results from merge. Okay, it tells us if the row or the observation matched or not. Well, let's tabulate that, see what we get. You can see I wrote tab for short. So it shows us here that we have master only 1 is a value. We have 10 of those, and we have matched observations, or 3, and we have 450 of those. So if we look at our data now, you see that we have these first 10 observations, or 8 here, I guess, sorry, not 10, that were only in the original data set, the master data set or data set 1. So these were CPI years that we didn't have baseball revenue for. We didn't have revenue for 97 all the way back to 1990, so these have no revenue or team names, right? There's nothing to match there. Now, all these observations in the middle matched because we did have 1998 CPI and we had baseball teams. And I can scroll down, you can see some missing here. You know, perhaps it would be easiest for us to sort by year. Let's do that. Let me sort by year and go back to browse. Okay, so you can see all of 1998 merged, all of 1999 merged, right? We scroll all the way down to the bottom. We should see some more missing observations or non-merging observations. We can see that 2013 and 14, I did have CPIs, but again, we didn't have baseball data. So it's always important when you merge two data sets that you make sure you get expected results. Here, we would expect not all years to match, but we would expect all baseball years to match, and they did. We don't have any merge equals 2, which would have mean the observation only came from the using or the second data set, the MLB data set. We didn't have any of those because all of our MLB observations did match with a CPI observation. Now, obviously, we don't want to keep these observations that don't contain baseball teams, so we want to drop those. And I can use a conditional if statement to do so. I can say drop if merge equals 3. Oh, no, not 3, but 1. And you can see those 10 observations were dropped. Alternatively, I could have typed keep if merge equals 3. Those are the ones we want to keep. Now here it says 0 observations deleted because I already dropped the ones that weren't equal to 3. Now you can see once I've done that, if I tabulate merge, all observations are matched observations. Therefore, that variable is not very informative anymore, so I can actually drop that variable. I can just type drop merge. And now we've cleaned up our data set. We don't have that unnecessary variable that's no longer informative hanging around. So now when I browse the data set, we can see we have our baseball data with this new variable CPI, which only changes if the year changes. It's the same for every year. That's great. Now, one way to check that, so here we said, you know, the CPI should not change across year. And this is a small data set, so we could just look at it and tell that that's the case. But if you have a huge data set and you want to make sure that's the case, something you could do is use what we learned in last video. So I'll give you a second, or maybe you should pause and think about how would you check this with a command that the value of the CPI does not change within year. And I'll give you a hint. You want to look by year. Okay, so hopefully you figured it out. Pause the video, came back. Here's how we could do this. If I want to make sure that variable does not change within year, I want to make sure the deviation is 0, meaning it doesn't change within year. So if I say by sort year, colon, I can tell Stata, remember, to do this command for separately for each value of year. I'm going to say summarize CPI. And what I expect to see and what I do see is that the standard deviation, the amount it changes typically, is 0 for each year. 2012, CPI had a mean value of 229.594, and it did not change. That was the minimum and maximum value, as we expect. And you can see that for each year. I can just scroll through here real quick and just eyeball and make sure that's the case. So this is another way I check data. Whenever something occurred, or whenever you made a change to your data, and in your head you say, I think this happened, you always want to find ways like this to check and make sure it is what you expected. And so this is one example. I can test that this variable is constant within year by summarizing by year and just making sure that standard deviation is 0 or that the min and max are the same number. Okay, fantastic. So what do we want to do with this data? Well, let's look at it again. Actually, let's look at it for just the Dodgers. That'll be informative. Let us browse if, and last time we learned that we could say team equals 14, because I don't want to type Los Angeles Dodgers and have a typo again. So here we're looking at the Dodgers across year. We're looking at their revenue. The revenue's going up. But does that mean they were earning more in real terms? Because what else was going up? The CPI, meaning the cost of goods and services were also going up. So some of that increase in the Dodgers revenue is because prices in general were going up. It doesn't mean the real value of the revenue was increasing. So let's convert all of these revenue dollars into 2012 dollars. And to do that, we will want to inflate the earlier years to be in terms of the later years. So for example, we don't want 1998 CPI 163. I'm sorry. For example, we don't want the revenue in 1998 107.9 million. That's 107 million actually. We don't want to know what that was in 1998 dollars. We want to know how much that would buy in 2012 dollars. Well, the amount that 107.9 million would buy in 98 is a lot more than it would buy in 2012. So what we want to do is we want to create a variable that will multiply this by, that'll scale it up to 2012 dollars. Now, how much should we scale this up by? Well, we need to scale this up by the percent by which the cost of living has increased between 163 and 229. However much that cost of living increased is the amount we want to increase this revenue so that it's the same purchasing power. To do that, we're going to need to create a new variable. Now, hopefully you took principles of macroeconomics and remember how to do this. This is a freshman year level exercise, but with data. So what we're going to want to do is generate a new variable. So I'm going to type generate, that's our new command, and I'm going to call this variable inflate. So whatever you type after generate will be the name of the new variable. So I'm choosing the name inflate because this is going to be our inflator. It's going to inflate the dollar amounts to be 2012. And what we want to do is make this equal to the CPI value in 2012 divided by whatever it is in the current year. So actually, let me go back. We need to know what the CPI was in 2012. Oh, well, luckily it's right here, 229,594. So I'm just going to copy that. So we want our inflator to be that divided by, I'm just going to type CPI, because what this is going to do is generate a variable called inflate that equals this value of the CPI in 2012 divided by whatever the CPI currently is. Now let's go ahead and browse that Dodger subset again. I'm going to go to history, click browse if team is 14. So you can see now we have our inflation variable. So obviously it equals 1 in 2012 because we don't need to change this dollar amount. It's already in 2012 dollars. You see here for 2011, the inflator is equal to 1.02. So what we're going to do is we're going to multiply revenue, this 230, by 1.02, which will increase it by 2%. And in doing so, it'll change the revenue into the dollar amount necessary to buy the same goods and services in 2012. In this way, the dollar amounts are comparable across the year. They're both in 2012 dollars. Now you can see as we go back, the amount we inflate in general is going to increase. So when we go all the way back to 1998, we're actually inflating the dollar amount by 40%. Think about what that means. That means the cost of living has increased 40% between 1998 and 2012. That's not a long time. Let's say that another way. If you had this $107.9 million sitting in a bank account, right, earning zero interest, or if you just, hid that amount of money in a safe underground and hopefully told nobody, it would be worth 40% less when you dug it up in 2012 because it would buy 40% less goods and services. Now think about that and apply that to your own life and realize how much faster inflation is eating up your money today. Actually, don't think about that right now. You'll get depressed and give up. Come back, come back. Let's just focus on Stata and sports. Okay, so we have our variable now, our inflation variable. What I want to do is create a new revenue, a real revenue. That's what we can call it because it's in real terms. And all we want to do is take this revenue and multiply it by this inflation rate. So let me show you how to do that. Let's generate another variable. We're going to generate, let's call it real revenue equals revenue. And then I'm going to say times that variable inflate. And times is shift 8. It's that star, right? You hold down shift and hit the number 8. It gives you that star symbol, which means multiply. Now let's go back to our data. And sure enough, this scaled up the revenue. Now let's do this. I'm going to drag revenue by inflate to make this comparison easier. So we took that $107.9 million. We inflated at 40%. We just multiplied these two. And what we found was that's the same real value in 1998 as $151.98 billion in 2012. So to say that another way, to purchase what you could have purchased for $107.9 million in 98, to purchase that same amount of goods and services, which is a lot, so maybe to purchase that amount of baseball teams, so that amount of professional sports teams if you're that wealthy, in 2012 would cost almost $2 million because of inflation. So as you can see, as we move up the years, the amount that revenue changes when we go from nominal to real isn't as much, right? This last one just goes from 230 to 234. And as expected, 2012 is already in 2012 dollars, so it doesn't change at all. But now we can use this variable, which is what you should be using, for any kinds of calculations when we're interested in the changes of a real value of a sports team. So I might have you calculate how has the real value of the New York Yankees changed over time, right? We can value this as an asset. If we're going to value this cash flow of revenue from the Yankees over time, we can now say in real terms if it was worth the purchase or not. Now we need to know how much it costs, how much the team costs, of course, but here we have our dollars in real terms. So we can know if holding on to the Yankees over the decades is worth it, then you would gain a real value by doing so. All right, and we've also talked about how to generate new variables. Hopefully that's obvious to you now. One last thing I do want to cover before we end this video is something I probably should have mentioned in the last one. So you just learned two new commands, merge and generate. You should read the help files on both. So recall to open the help file, you could just type help, and then I'm going to say generate. Let's open that one. And again, this will tell you how to use the syntax, what options you can use, It will give you some examples at the bottom, but these help files are a little brief and sometimes you want more details, especially when we start getting into the more complex commands. For that, you can click this link here, View Complete PDF Manual Entry, and Stata will open up a PDF window, which I will have to drag over to the screen. So here's the PDF it opens up. Now this is a great resource. These books would cost thousands of dollars decades ago before they were available in PDF format. Not everybody had access to these entries, and those professors that did had to spend over $1,000 to get the books that had this information printed. Now it comes with Stata. So you can click these links to go to straight to examples if you want, but this PDF has much more information on the commands, right? And it also shows you what you should be seeing when you type in the examples. If you look over here to the left on these bookmarks in Adobe, these are all the different books that you can open and look and search for help. There are a tremendous amount of books here and information. The one I suggest you all read on your own as soon as possible is this user's guide, the U book. Now, if I expand that, you see there's contents, Stata basics, so on and so forth. If we go to the user's guide, which you can open from any PDF entry, it's less than 30 pages, I think. You should read this from cover to cover. Again, less than 30 pages. And it tells you basically all the basic things you need to know about Stata to begin. I'm giving you what you need to perform in this class, but for a real, more thorough learning of how to use the program, you really should read this. The way I learned Stata in graduate school is I purchased Stata. This small book came with it. It was a physical book. I read it over the weekend, and by the next week, knew more about Stata than most of the other grad students who had already taken a class in Stata. So this is an assignment. You must read this U book that is in the PDF help section, and it'll teach you even more basics than these videos went over. Of course, if you have questions over any of that, you can reach out to me, and I can help you understand it if you need some more help. All right, guys, have fun.